What if we were never alone? It is a question that lingers at the edge of imagination, half-formed, half-whispered, surfacing only in the quiet moments when the familiar patterns of history feel too simple, too neat. We are told that Homo sapiens, our species, emerged, struggled, survived, and slowly spread across the globe. We are told that we are the singular intelligence, the only true makers of cities, languages, and symbols. But what if the story is not so linear? What if, long before writing, long before agriculture, even long before the first flicker of recorded myth, another intelligence shared the earth with us? Imagine stepping outside on a cool night. Stars glittering overhead. The world feels still, ancient, unchanging. And yet beneath your feet lies a planet in constant motion, geology grinding, ecosystems shifting, whole worlds rising and falling beyond the span of any memory. Within that vast stage, how certain can we be that humanity has always been the only actor? The fossil record, for all its value, is like a library whose shelves are mostly empty. Every now and then we stumble upon a page, an artifact, a bone, a tool, and from those fragments we attempt to reconstruct the whole book. But the silences are immense. Most species leave no trace at all. Entire landscapes are swallowed by time, their memory scattered or erased. And so the question arises, subtle but persistent. Could there have been another species, intelligent and self-aware, whose story unfolded parallel to ours, or perhaps long before ours began? A species that built, dreamed, and perhaps even asked the same questions we now whisper into the dark. We imagine ourselves as unique, the culmination of a long climb toward consciousness. But Earth's age humbles that notion. Our planet is over 4.5 billion years old. Modern humans have walked it for perhaps 300,000 years, a fraction of a fraction, less than the final stroke on a clock face stretched across eternity. In such immensity, how certain can we be that intelligence only arose once? If we frame the question honestly, it becomes less about wild speculation and more about humility. We do not ask, did they exist, in the definitive sense. We ask instead, if they existed, how would we ever know? Because time is not gentle. It wears away not only the bodies of creatures, but the legacies of civilizations. Rock is the memory of Earth, and even rock forgets. Picture this: another species, different in form, perhaps upright, perhaps not, thriving in a forgotten landscape. They leave behind camps, tools, artworks, maybe even rituals of meaning. And then the ages turn. Ice sheets advance. Rivers carve new valleys. Volcanoes bury plains. What remains of their world is not ruins we can walk through, but whispers, traces too subtle to stand apart from geology itself. If we were to stumble across those whispers today, would we even recognize them? In the silence of deep time, possibilities expand. Myths from across the world speak of the others, giants, hidden peoples, strange teachers who appeared and vanished. Science, too, speaks of cousins, Neanderthals, Denisovans, and small-bodied Homo floresiensis, each intelligent in their own way, each living alongside us for a while before fading. These are reminders that we are not as singular as we imagine, and they are hints that the line between us alone and us among others is thinner than it seems. So here, at the threshold of this exploration, we pause with the question still in our hands. What if we were never alone? Not aliens from the stars, not myths from the edges of imagination, but another intelligence born of the same earth, sharing the same sky and walking the same soil? The answer may be hidden in stone, in chemical signals, in myths, in anomalies, or perhaps it is gone forever, erased by the patient work of erosion and fire. Either way, the question itself invites us to lean closer to the silence of deep time and listen, not for certainty, but for possibility. Because if another species once walked beside us, then the story of humanity is not a solitary tale. It is a dialogue, an unfinished chapter in a much longer book. And perhaps the truest mystery is not whether they were here, but whether we would ever notice if they were. When we ask if another intelligent species once shared the Earth with us, we must immediately confront a sobering reality. Proof may never come in the form we expect. We imagine ruins, vast stone temples, buried machines, fossilized cities waiting for discovery. But this expectation comes from the short span of our own memory. In truth, over the scales of tens or hundreds of thousands of years, almost all such structures would vanish. So instead of asking, "Where are the ruins?" we might better ask, "What signals could endure?" The difference between proof and signal is subtle but vital. Proof is undeniable, a clear artifact held in the hand. A signal is fainter, a trace, a whisper carried across ages, suggesting but never fully confirming. Science, after all, is built not only on what we find, but on what patterns emerge when we look deeply enough. Think of the way we recognize the presence of ancient volcanoes, not by standing at their rims, but by reading ash layers in distant rock. Or how we understand ice ages not through photographs, but through isotopes trapped in bubbles of ancient ice. In the same way, the traces of another intelligence, if it ever existed, may be subtle, folded into the planet's chemistry, biology, or geology. Signals could come in many forms. A sudden shift in the balance of carbon isotopes in a rock layer, something unusual that doesn't match volcanic activity or asteroid impact. A chemical residue in a cave wall, pigments mixed in ways that imply deliberate choice rather than accident. A pattern of bones in a landscape that hints at overhunting or ecological engineering. Each of these on its own could be explained as natural. Together they might suggest something more, and yet we must tread with caution. The natural world is endlessly inventive. Geological forces carve landscapes that mimic architecture. Mineral veins form shapes that resemble tools. Even the growth of crystals can look at first glance like deliberate design. Signals are not proof. They are invitations to look closer, to test, to remain open without rushing to conclusion. Imagine, for instance, if future geologists examined the layers of our present day 100,000 years from now. They would not find intact cities, but they might notice the sudden spike of carbon in the air, locked into sediments. They might find synthetic molecules, plastics reduced to microscopic fragments, scattered through soils and seas. They might encounter isotopic anomalies from nuclear testing, radioactive fingerprints unlike anything produced by natural decay. To them, those would not be monuments or machines. They would be signals. This is why signals matter. They remind us that if another intelligent species once altered the Earth, we should not expect their legacy to be written in stone monuments. We should expect it to be encoded in subtler ways, in the chemistry of rocks, in the distribution of fossils, in the quiet deviations from what is otherwise natural order. There is a humility in this. It requires us to admit that certainty may never come, that we may live in a world filled with faint echoes rather than undeniable voices. But perhaps that is the true shape of deep time. Not proof, but signal. Not declaration, but whisper. And so when we search for traces of another intelligence, we search not for ruins, but for patterns. Not for certainty, but for possibility, because possibility is all that time is willing to leave us. For much of the 20th century, humans imagined themselves as a solitary species, the sole bearer of intelligence in a vast evolutionary tree. School books taught us that we were the singular survivors, that Neanderthals were crude and brutish, and that beyond them there was little worth remembering. But over the past few decades, that picture has shifted dramatically. We now know that humanity was never truly alone. For tens of thousands of years, our world was shared with cousins, other species of humans, each with their own ways of living, their own forms of intelligence, their own voices in the chorus of life. Neanderthals are perhaps the most familiar. Far from being the lumbering caricatures of early illustrations, they were toolmakers, hunters, and storytellers in their own right. They lived in harsh, Ice Age environments, survived long winters, and cared for their sick and injured. Evidence suggests they made art, engravings, beads, pigments, symbols that may have carried meanings we will never fully know. They were not a failed experiment, but a parallel form of humanity, and they thrived for hundreds of thousands of years before merging, in part, with us. Then there were the Denisovans, a species whose very existence was only revealed by a fragment of a fingerbone and traces of DNA in a Siberian cave. We know little of their appearance, but their genetic legacy endures in millions of people today, particularly in parts of Asia and Oceania. Some of their genes may even aid adaptation to high altitudes, as seen in Tibetan populations. Their presence whispers of a humanity broader and more complex than we once believed. And further afield, on the island of Flores in Indonesia, the discovery of Homo floresiensis startled the scientific world. Standing barely a meter tall, with small brains but evidence of tool use and fire, they were nicknamed hobbits. For thousands of years, they shared the earth with larger humans, persisting in isolation until just tens of thousands of years ago. Their existence challenges our assumptions about what intelligence looks like and what forms it may take. Add to this list Homo naledi, found in South Africa, small-bodied, with a curious blend of ancient and modern traits. They too may have engaged in ritual, perhaps even burying their dead. And there may yet be others, undiscovered, their bones buried in caves or deep beneath sediments, waiting for the day someone recognizes them as kin. What does all this tell us? That the human story is not one of isolation, but of diversity. We were never a single thread, but a tapestry woven from many species, some interbred with us, some faded quietly into extinction, some left only whispers in our DNA, but together they form a reminder. Intelligence is not unique to us. It is not bound to one form, one species, or one history. If so many cousins could exist within the span of a few 100,000 years, why should we dismiss the possibility that intelligence might have risen in other, stranger forms before them? If Neanderthals could craft jewelry and Denisovans could pass on adaptations still alive in us, then perhaps intelligence is not a singular accident, but a recurring theme, a melody Earth has played more than once. Picture this: a world not of one human species, but of several living side by side, each shaped by their environment, each with their own gifts, some large, some small, some rugged and strong, others subtle and inventive. It is a humbling vision, one that reframes our place not as the inevitable outcome of evolution, but as one among many possible branches. The fossil record proves this much beyond doubt. We have always been a family of many kinds, And if we accept that, then the step to wondering whether other kinds of intelligence rose before us becomes not fantasy, but simply an extension of what we already know. To begin understanding why the traces of another intelligent species may be so difficult to detect, we must first step into a concept that feels alien to human thought: deep time. We measure our lives in years, decades, perhaps a century if fortune allows. Our histories stretch back thousands of years, and our myths claim memories of even older times. But deep time is measured in millions and billions. It is the scale of continents drifting, mountains rising and crumbling, oceans appearing and disappearing. On this scale, human history is less than a blink, less than the last syllable in a book too vast to hold in the mind. Consider this: Earth is over 4.5 billion years old. The dinosaurs, who feel ancient in our imaginations, lived from about 230 million to 66 million years ago. That span itself, over 160 million years, is nearly incomprehensible. Yet even it occupies only a fraction of Earth's life. Humans, by comparison, are infants. Modern Homo sapiens emerged around 300,000 years ago. Our industrial civilization, barely 2 centuries old. When we compress Earth's history into a single calendar year, the scale becomes clearer. On that scale, life begins in late March. Dinosaurs appear around mid-December and vanish by December 26th. Homo sapiens appear at 11:58 p.m. on December 31st. All of recorded history, from the pyramids to the present, unfolds in the final seconds before midnight. What happens to memory across such scales? It vanishes. Most of the Earth's surface is younger than 200 million years because tectonic plates constantly recycle themselves. Ocean floors are born at ridges and destroyed in trenches, their crust pushed back into the mantle to melt and reform. Mountains rise and erode to plains. Ice sheets grind landscapes to rubble. Rivers shift and carve new valleys. The Earth, for all its stability beneath our feet, is in truth a restless and forgetful planet. This means that even if an intelligent species flourished 100,000 years ago, or 1,000,000 or 10 million, their physical traces would be at the mercy of forces larger than any civilization. A city left to the wind and rain might crumble in centuries. In thousands of years, it would be buried. In millions, it could be ground to dust, folded into mountains, or subducted beneath seas. Think of the most enduring creations of our world today: the tallest skyscrapers, the strongest bridges, the densest concrete. Left untended, they would not last. Iron rusts, concrete fractures, plastics, though persistent, break down under sun and microbes. Even glass becomes brittle and shatters into grains. Given enough time, nature reclaims everything. Within 10,000 years, our cities would be unrecognizable ruins. Within 100,000, even those ruins might be erased, and beyond 1,000,000, there might be nothing at all. The fossil record itself bears witness to this silence. Fossils are rare because preservation is rare. An organism must die in the right place, be buried quickly, and remain undisturbed for unimaginable spans of time. Most species that ever lived left no fossil at all. Entire ecosystems, forests, wetlands, coral reefs, flourished and vanished without leaving behind a single bone or leaf. What we see today is not a complete record, but a biased sample, a few scattered pages from an almost entirely lost story. So when we say there is no evidence of another intelligent species, what we truly mean is that no enduring signals have yet been found. But absence is not certainty. Absence may simply reflect the silence of deep time, a silence so profound it swallows almost everything. Picture this, a bustling settlement of another kind of being, thriving near a coastline. Fires glow at night, tools are made, stories are shared. Then, over the ages, sea levels rise. The land is drowned, sediments drift, storms scatter the remains. In the end, nothing survives but faint chemical residues in layers of mud, layers that millions of years later may themselves be ground into stone and lost again. Deep time erases not only the fragile but also the mighty. It cares nothing for intelligence, for art, for meaning. It devours equally the bones of the humble and the monuments of the great. And this is why the earth feels, to us, so silent. Not because nothing happened, but because almost everything has been forgotten. The silence of deep time is not empty, though. It is filled with possibility. It reminds us that the history we know is but a fragment, and that the true scope of Earth's story is wider, older, and more mysterious than we can imagine. When we look backward into the past, it is tempting to equate what we see with what was. The pyramids, the temples of Angkor, the stones of Stonehenge, these loom in our imagination as markers of permanence. They seem eternal, standing against time. But even these monuments are fragile. Left alone, they crumble. Covered by jungle or buried by sand, they vanish from human memory until rediscovery breathes them back into awareness. Memory, whether cultural or geological, is fragile. It requires survival against immense odds. A manuscript must escape fire and mold. A city must avoid being ground down by glaciers. A fossil must be buried in the precise conditions that allow preservation. The fact that anything endures at all is remarkable. Now consider how much is lost. Human culture extends tens of thousands of years into the past, but we hold only scraps. We marvel at the cave paintings of Lascaux, but they are a tiny fraction of the art that must once have adorned ancient walls. We study chipped flints and bone tools, but these survive only because stone and bone endure longer than wood, fiber, or leather. What if our ancestors made instruments of music, structures of timber, or garments of woven grass? These would have vanished without trace. If memory fades so easily within tens of thousands of years, what hope would there be for anything 100,000 years old, or 1,000,000, or more? Scientists sometimes speak of preservation bias. It means that the record we see is skewed toward what nature allows to survive. Hard bones fossilize, stone tools persist. But softer, subtler things, cloth, ritual, symbolic art carved in organic matter, disappear. The silence of the record is not the silence of history. It is the silence of memory lost. This matters when we imagine the possibility of another intelligent species. If their tools were made of wood or bone, or even more delicate organic composites, they would not survive. If their structures were woven or sculpted in earth, they would have eroded long ago. If their symbols were spoken rather than carved, they would vanish in the air. Even if their presence were recorded chemically, in pigments, in residues, in the altered distribution of species, those records too are fragile. They can be erased by fire, by flood, by the grinding of tectonic plates. This is why no evidence is not the same as no existence. To say we have not found something is only to say it has not endured, or that we have not yet looked in the right place. Consider how easily our own memory could be erased. Imagine that humanity vanished tomorrow. Within a few decades, our cities would be covered in vines, our steel structures collapsing. Within centuries, most of what we built would be gone. Within millennia, only fragments might remain, buried plastics, faint traces of isotopes in rock. Fast forward 100,000 years, and perhaps the only signals of our existence would be slight anomalies in the chemistry of stone. And then imagine a new intelligence rising millions of years from now. They might dig through those layers and see nothing unusual, or they might find faint chemical signals. Would they interpret them as evidence of a vanished civilization, or dismiss them as natural processes? Would they recognize us, or would we too become a forgotten possibility? Memory is fragile. It fades not only from minds, but from the very earth itself. What we call history is only what survived the erasures of time. And those erasures are relentless. This fragility humbles us. It reminds us that even if another intelligent species once lived here, we should not expect monuments. We should expect whispers, faint and fragile, always on the edge of silence. If human memory is fleeting, and if artifacts crumble, then what holds the deeper record of our planet's story? The answer is simple, yet profound. Rock. Rock is the memory of Earth. Every layer of stone is a page in the planet's long chronicle, written not with ink but with minerals, isotopes, and fossils. Each stratum of sediment is a snapshot of a vanished world. Oceans that once covered plains, forests that rose and fell, rivers that carved and then abandoned their valleys. Rock remembers what flesh forgets. It carries echoes of mass extinctions, of climates long gone, of lives that once teemed in abundance and are now dust. To a geologist, the Earth is a vast library. Sandstone speaks of ancient deserts where wind carved dunes into stone. Shale whispers of oceans that lingered for millions of years before retreating. Coal beds recall dense forests of the Carboniferous, pressed into black layers by time. Even ice, in the form of ancient glaciers, leaves behind its inscriptions. Grooves in stone, erratic boulders, moraines left like punctuation marks. But rock is not a perfect memory. It is a memory under constant revision. Tectonic plates fold and twist it. Heat and pressure rewrite it into new forms. What survives is not the complete book, but fragments, sentences scattered across continents, paragraphs torn from context, rewritten by fire and erosion. If another intelligent species once walked the Earth, rock is where we must look for their traces. We should not expect statues, but signatures, not monuments, but anomalies. Rock holds chemical signals more enduring than architecture. If a civilization once burned fuels, the ratios of carbon isotopes may still linger in sediments. If they mined or smelted metals, trace concentrations of unusual elements might remain locked in stone. If they experimented with pigments or fire, microscopic residues could persist in caves, protected from weather and time. Even DNA, fragile as it is, can be preserved in the right conditions, frozen in permafrost, trapped in ancient sediments, or fossilized within bones. Already, more genetic studies have revealed the presence of unknown hominins, ghost populations whose names we may never know, but whose existence is still written in our bodies. Rock remembers them even when history does not. But rock's memory is not simple to read. Natural processes often mimic artificial ones. A layer rich in carbon might point to ancient industry or to volcanic eruptions. Metallic concentrations could be residues of smelting or deposits from hydrothermal vents. Patterns etched in caves might be art or the byproduct of mineral seepage. The language of rock is subtle, and it is easy to mistake its meaning. Still, if another species of intelligence once flourished here, rock is the only witness likely to remain. The cities may be gone, their walls ground to dust, The tools may be corroded beyond recognition, but somewhere, buried deep in strata, there could still be a signal, a layer that whispers, something happened here. Something that was not merely natural, but intentional. Picture this: a cliff face cut open by time. Within its layers, bands of color and texture tell a story. The rise of seas, the fall of forests, the silence after an extinction. And then, perhaps, a thin line of anomaly. A sudden shift in chemistry, subtle but sharp. A deviation that does not fit the rhythm of volcanoes or meteors. A trace of choice, of fire, of intelligence. A single line in a vast book, but one that changes the meaning of the whole. That is the promise of rock. Fragile as memory may be, stone endures. And though it forgets much, it remembers enough to remind us that the earth has a story far larger than ours, and perhaps one in which we are not the only authors. If rock is the memory of Earth, then chemistry is the script written within it. The composition of minerals, the ratios of isotopes, the faint traces of residues, all of these hold hints of events that would otherwise be invisible. For those who seek to imagine whether another intelligent species once shared our world, chemistry may offer the most enduring and subtle signals. Let us begin with carbon. Life has always left its imprint in the balance of carbon isotopes. Most living organisms favor carbon-12 over carbon-13, a quirk of biology. When vast forests grow or when oceans teem with algae, the ratio of these isotopes shifts. When they die and decompose, the record is locked into sediments. Now imagine the sudden burning of enormous amounts of organic matter. Forests cleared by fire, or even fossil fuels consumed in vast quantities. This, too, leaves a mark, a spike of carbon-12 that can endure for millions of years. We know this because we are leaving such a signal ourselves. Today, geologists speak of the Anthropocene, an epoch in which human activity is reshaping the planet's chemistry. Our burning of coal, oil, and gas has released ancient carbon back into the air, altering isotope ratios in a way that will persist in rocks and ice long after our cities have crumbled. If another species ever sifts through those layers, they will see our presence in chemistry, if not in monuments. But carbon is not the only clue. Fire itself leaves residues, microscopic traces of ash, soot, and altered minerals. Early humans tens of thousands of years ago already left behind signals of hearth fires in caves, detectable today by subtle chemical changes in stone. If a parallel species had mastered fire in their own way, whether for warmth, cooking, or metallurgy, they too might have etched such signals into the record. Pigments tell another story. Red ochre, manganese, and other minerals have been used as symbolic materials by humans for at least 100,000 years. When such pigments are ground and applied deliberately, they can leave stains in caves and on artifacts that endure far longer than organic materials. If another intelligent species painted or marked their world, chemical residues of these pigments may still linger. And then there is metallurgy, the controlled use of metals, whether for tools, art, or ritual. Smelting leaves behind slag, an unnatural byproduct rich in certain elements. Even if the tools themselves corrode away, the slag can survive, fused into stone. An unexpected concentration of copper, lead, or rare earth elements in ancient layers could point to activity not explained by volcanoes or natural leaching. To this list, we might add more speculative signals. Synthetic molecules, for instance, do not usually occur in nature. Modern plastics, pesticides, and fluorinated compounds will leave traces in soils and sediments for millennia. If another species once engineered materials unknown to geology, faint remnants could, under the right conditions, remain detectable. But again we face the ambiguity of nature. Volcanic eruptions can mimic carbon spikes. Lightning strikes can fuse sand into glassy fulgurites, resembling industrial waste. Bacterial mats can produce mineral patterns that look artificial. The Earth, in its restless creativity, often blurs the line between the natural and the artificial. This is why chemistry offers not proof, but possibility. It asks us to look for clusters of anomalies, not single events. A spike in carbon isotopes, paired with unusual metal concentrations, paired with residues of pigments. Together, these could suggest more than nature alone. Picture this: a cave wall, dark and quiet for tens of thousands of years. On its surface, under the microscope, are grains of pigment, deliberately ground and applied. Nearby, in the sediments, a subtle change in carbon isotopes suggests repeated fires. In deeper strata, traces of rare metals appear, not easily explained by volcanic processes. Each clue, taken alone, could be dismissed, but together they form a chorus of whispers, hinting at hands and minds that once shaped the world in ways we are only beginning to recognize. Chemistry is not dramatic. It does not give us statues or inscriptions, but it is persistent. In the end, it may be chemistry that carries the most enduring memory of intelligence, ours or another's. When chemical whispers draw our attention, the next step is to turn toward the physical record, the shapes of stone, the arrangements of bone, and the traces of DNA hidden within them. These are among the most tangible forms of memory the Earth offers us, though even they are fragile, incomplete, and often ambiguous. Stone is where archaeology usually begins. Tools carved from flint, obsidian, or other hard materials are among the most enduring artifacts of early humans and their relatives. Chipped edges, symmetrical forms, and patterns of wear are not easily mimicked by chance. A sharp blade napped from stone tells us that a mind was at work, choosing, shaping, refining. Yet here, too, interpretation is a challenge. Some of the earliest supposed tools turned out to be geofacts, rocks fractured by natural forces, mistaken at first for human handiwork. The line between chance fracture and deliberate craft is thin, and it requires context, many pieces found together, patterns of use, to be certain. Bones also carry traces of intelligence, though not always in obvious ways. Cut marks on animal remains suggest butchery. Piles of broken bones may signal feasting or ritual. Burials, where bodies are placed deliberately with care, are powerful signs of culture. Neanderthals, for example, left behind graves with flowers and pigments, small gestures that reveal thought and meaning. But bones are vulnerable. They decay quickly unless sealed in caves, frozen in permafrost, or buried in sediments that protect them from air and water. For every skeleton we recover, countless others must have vanished without a trace. DNA adds another layer to this record, a molecular echo carried forward in time. Ancient DNA has revealed the existence of entire human lineages, such as the Denisovans, from the faintest of fragments. Today, geneticists can extract DNA not only from bones, but from sediments themselves, reading the biological signatures of creatures that once walked across a cave floor. Such methods may yet uncover evidence of populations we never knew existed, populations whose stories are absent from both history and myth, but preserved in molecules. But the most intriguing clues may not be in isolated tools, bones, or strands of DNA, but in patterns that suggest ecological change. Consider the possibility of overhunting. If a species, intelligent and organized, hunted animals beyond natural balance, the fossil record might show a sudden decline in certain prey. Or imagine a species that shaped landscapes, burning forests, redirecting rivers, cultivating plants. Such acts could leave scars detectable thousands of years later, even if no artifact survives. Picture this: a valley rich with fossil remains. In one layer, diverse megafauna thrive: giant deer, wild horses, large predators. In the layer above, many are suddenly absent. The bones that remain show cut marks, splintered for marrow. Charcoal traces mingle in the soil. To us, this may read as a signal of human activity, yet who is to say it could not belong to another, now forgotten intelligence? Yet, as always, nature offers mimicry. Extinctions can be driven by climate, not hunters. Fires can rage from lightning, not deliberate hands. Rivers shift on their own, leaving patterns that resemble irrigation. The earth produces its own illusions, and we must remain cautious in interpretation. Still, stone and bone, with all their limitations, are durable teachers. They remind us that intelligence leaves traces not only in artifacts, but in the very fabric of ecosystems. When a mind acts upon the world, it rearranges matter in ways that may endure. If another intelligent species once lived here, we must also reckon with the forces that could erase almost every trace of their existence. Earth, for all its fertility, is also a planet of catastrophes. Time does not pass gently. It is punctuated by resets, moments when the slow rhythm of geology is interrupted by violence, wiping away worlds in the span of days or years. The most famous of these resets is the event that ended the reign of the dinosaurs. 66 million years ago, a massive asteroid struck what is now the Yucatan Peninsula, releasing energy equal to billions of nuclear weapons. Firestorms swept continents. Tsunamis tore across oceans. Dust and sulfur choked the skies, plunging the planet into a long winter. Within a geological instant, 3/4 of Earth's species were gone. This moment, the K-Page extinction, is written in rock as a thin layer of iridium-rich clay found all around the globe. It is the signature of an apocalypse. But that was not the only time Earth has reset itself. About 252 million years ago, the Permian-Triassic extinction, sometimes called the Great Dying, wiped out nearly 90% of species. The cause was not a single impact, but a cascade of volcanic eruptions in what is now Siberia, releasing immense quantities of greenhouse gases. Oceans turned acidic, temperatures soared, whole ecosystems collapsed. For millions of years afterward, life limped through a slow recovery. Even in more recent times, the planet has delivered devastating blows. Supervolcano eruptions, such as the one at Toba in Indonesia around 74,000 years ago, may have caused a global volcanic winter. Human populations dwindled, and it is possible that entire cultures were erased. Ice ages, too, reset the map, grinding landscapes beneath glaciers, burying valleys, and drowning coastal plains as seas rose and fell. Each of these events reminds us of how fragile life is, and how easily memory can be destroyed. If another intelligent species once flourished before us, they would have been vulnerable to the same forces: an asteroid impact, a supervolcano, a sudden shift in climate. Any of these could erase their settlements, scatter their artifacts, and leave only silence behind. Imagine for a moment that humanity vanished in such a catastrophe. What would remain? Our skyscrapers would fall. Our bridges would collapse. Within centuries, forests would cover our cities. Within millennia, glaciers could scrape the land clean. Within tens of thousands of years, rivers and winds would scatter all but the deepest traces. What might endure would be only the faintest chemical fingerprints, carbon isotopes, fragments of plastics, residues of metals. For future intelligences, we would not appear as a civilization, but as a subtle anomaly in stone. Resets do not erase the Earth itself, but they do erase continuity. They sever the thread of memory. After each cataclysm, the survivors, whether humble or complex, inherit a new world, often without knowledge of what came before. This is why so much of Earth's story feels like it begins again and again, each age a fresh start. If there was once another intelligent species, we may never know their name, their shape, or their dreams. They could have been erased, not by failure, but by catastrophe. Wiped away in a reset so complete that only whispers remain in rock and myth. If stone and chemistry offer the hard evidence of Earth's past, then myth provides something softer, an echo, fragile and shifting, passed not through rock, but through memory. And yet, myths may be worth listening to, for they carry the possibility of deep cultural memory. Across the world, stories of the others appear again and again. Giants who walked the land, little people who lived in forests and caves, hidden teachers who came in ancient times to bring knowledge, fire, or order. Often these stories are dismissed as invention, the imaginative fabric of pre-scientific minds. But what if they are more than that? What if they are distant recollections of times when humanity was not alone? Consider the giants of Norse mythology, the Jötnar, who inhabited the world before the age of humans and gods. In Native American traditions, too, there are stories of ancient giant beings, sometimes adversaries, sometimes kin. In the forests of Siberia and Central Asia, tales endure of wild, human-like beings, the almas, the chuchuna, said to dwell beyond the reach of ordinary life. Even in Europe, medieval chronicles mention woodwoes or wild men, strange figures said to haunt the margins of civilization. These echoes are not confined to one culture. In Aboriginal Australia, Dreamtime stories describe ancestral beings who shaped the world and then disappeared into the landscape. In Polynesia, tales speak of hidden races, some benevolent, some hostile, who once shared the islands before fading into legend. And in the Sanskrit epics of India, we find descriptions of vanished peoples, strange beings who interacted with humans before being swept aside by floods, wars, or divine punishment. We do not have to take these stories literally. Myths evolve, adapt, and blur. Over centuries, natural events are woven with symbolism. A great flood becomes a lesson about morality. A vanished people becomes a tale about pride and downfall. But still, beneath the changes, there may linger a kernel of truth, a memory of encounters with others who were not quite like us. Archaeologists have long noted that myths sometimes preserve genuine historical events. In Australia, oral traditions describe coastal lands swallowed by the sea. For decades, these were thought to be symbolic tales, until researchers realized that the stories correspond to real sea level rise events more than 7,000 years ago. Myths, in this sense, can preserve memory across astonishing spans of time. So why should we not allow that myths of others may contain similar fragments of truth? Perhaps they recall meetings with Neanderthals, Denisovans, or other human species now gone. Or perhaps they reach further, carrying distorted memories of something even older, something that once lived alongside us before time and catastrophe erased them. Picture this: a community gathered around a fire, tens of thousands of years ago. Elders tell stories of the mountains, of strange people who once lived in caves nearby, larger, stronger, or smaller and more cunning. These stories are passed down, generation after generation. The details shift, gods and monsters enter. Yet the memory persists. We were not alone. By the time it is written down in myth, it is poetry more than history. But perhaps the poetry still points to something real. We must be careful, of course. Myths cannot serve as proof. They are not evidence in the scientific sense. But they are signals, cultural signals, that suggest how deeply the human imagination has been haunted by the idea of others. And the universality of such stories across continents hints that they may not be inventions born in isolation, but echoes of real encounters long forgotten. Myths are quiet echoes. They do not speak clearly, but they invite us to listen. And when we place them beside the geological and archaeological record, they become part of a larger tapestry, one in which the possibility of shared existence is neither fantasy nor certainty, but a question worth asking. From time to time, discoveries surface that seem to defy the neat story we tell of history. A hammer encased in rock, a pot found in a lump of coal, carved stones appearing in layers far older than expected. These so-called out-of-place artifacts, ooparts as they are sometimes known, stir fascination, controversy, and debate. Most are eventually explained by natural processes or by errors in reporting. Rocks fracture in strange ways. Minerals crystallize into shapes that mimic the symmetry of human craft. Objects can be moved by floods, landslides, or mining, ending up embedded in sediments that seem older than they truly are. The Earth is endlessly inventive, and the human eye is quick to find patterns. Yet the allure of ooparts persists, because they remind us of how much remains unknown. Even when a claim is dismissed, the very idea lingers. What if one day something undeniable is found? An object so anomalous it cannot be explained away. One of the most famous examples is the Antikythera mechanism, discovered in a shipwreck off the coast of Greece. It is not an artifact from deep time. It dates to around 2,000 years ago, but its complexity startled historians. A machine of gears and dials capable of predicting astronomical events, it was centuries ahead of its time. Its existence reminds us that technology can appear earlier than expected, only to vanish and be forgotten. If that is true within recorded history, how much more might have been lost in prehistory? Other claims are more controversial. Reports exist of metal spheres found in South African mines, allegedly in rock layers billions of years old. Most geologists argue these are natural concretions, spherical mineral formations that emerge from geological processes. But their unusual grooves and symmetry have fueled speculation. Similarly, there are stories of nails or tools found in coal seams, though these are often poorly documented and likely to be accidents of contamination. These anomalies, whether real or misinterpreted, serve an important role. They push us to remain open to possibility. They remind us that our assumptions about the past are always provisional, built on the limited evidence available. They also highlight how fragile context is. Without careful excavation and documentation, even a genuine discovery can be lost to skepticism or misinterpretation. Picture this: a geologist breaking open a rock face and finding within it an object unmistakably artificial, a shape of precision, not accident. Imagine the debates, the attempts at explanation. Did it fall into a fissure and become encased? Was it contamination from a later age? Or was it truly what it seemed? A fragment from a time far older than our history allows. For now, no verified object has proven the existence of another intelligent species in Earth's past. But the allure of OOPArts lies less in what has been found and more in the reminder that what we expect to find shapes what we recognize. An anomaly today may be dismissed. Tomorrow, with new understanding, it might be recognized as something extraordinary. In this way, OOPArts serve as cultural artifacts of our own curiosity. They show how ready we are to imagine hidden histories, how eager we are to peer into the gaps of time and wonder what might have been. Takeaway: out-of-place artifacts are rarely what they first appear, but they reflect our deep curiosity and the possibility that one day something undeniable may be found, an object that forces us to expand the timeline of intelligence on Earth. When we look for traces of intelligence in the distant past, we walk a razor's edge. On one side lies the temptation to dismiss anomalies too quickly, to explain away every unusual pattern as coincidence or natural process. On the other side lies the danger of overinterpretation, of seeing deliberate design in what may be entirely natural. Both errors distort the truth. The Earth itself is a master craftsman, capable of creating forms that mimic intention. Minerals crystallize into shapes of striking geometry, cubes, hexagons, perfect spheres that look as though they were designed. Lava flows create columns of stone that rise like man-made walls. Erosion carves landscapes that resemble statues, faces, or cities. To an untrained eye, these illusions are compelling. Even to scientists, the distinction is not always obvious at first glance. Biology, too, produces patterns that invite misreading. Termite mounds tower like cathedrals. Coral reefs form sprawling structures that rival cities in scale. Beavers dam rivers, altering entire ecosystems. These are non-human intelligences shaping their environments, but not in ways we would call civilization. If we found the fossilized remains of such activity without knowing its source, might we mistake it for something more? Even chemical signals can mislead. A spike in carbon isotopes might suggest widespread burning by intelligent beings, but it could also result from a massive volcanic eruption. Traces of metal in rock might seem like evidence of smelting, but hydrothermal vents can produce similar concentrations. Charcoal in sediments could indicate fire pits or simply ancient lightning storms. The risk, then, is not only in what we miss, but in what we misread. To see intention where there is none is to create phantoms, false histories that obscure rather than reveal. Yet to dismiss too readily is to risk overlooking what may be real. Science navigates this tension by demanding multiple lines of evidence. A single anomaly is not enough, but a pattern, a cluster of signals across disciplines, becomes harder to ignore. Archaeology, geology, chemistry, and biology must converge, their whispers aligning into something like a voice. Only then can we begin to speak of intelligence with caution and confidence. Picture this: a cave floor rich with charcoal, pigments smeared across walls, and nearby bones bearing cut marks. Alone, each of these could be natural. Together, they suggest deliberate hands at work. Now imagine similar signals in a layer far older than expected, perhaps hundreds of thousands of years deep. How would we interpret them? With skepticism, yes, but also with humility, acknowledging the possibility that our assumptions about history may be incomplete. This is why the search for another intelligent species in Earth's past is not only about evidence, but about discipline. It requires us to balance curiosity with caution, wonder with rigor. To read the record not as a story we wish to find, but as one that emerges slowly, carefully, from the fragments time allows us. The risk of misreading is real, but so too is the risk of silence, of refusing to imagine that the story could be larger than we have been taught. Between these two risks lies the path of honest inquiry. Takeaway: the natural world often mimics intelligence, making misinterpretation a constant danger. True signals must be distinguished from illusions by patterns across multiple forms of evidence, requiring both caution and openness. Sometimes the best way to explore possibility is not through evidence, but through imagination carefully guided by science. So let us attempt a thought experiment. Imagine that another intelligent species once shared the Earth with us, or even thrived long before us. What would remain if they vanished overnight? Picture a world in which, tomorrow, humanity disappears. No wars, no disasters, simply absence. Our cities are left standing, our machines silent, our satellites orbiting above. What happens next? In a matter of weeks, nature begins its slow reclamation. Streets sprout weeds, birds nest in abandoned towers, domestic animals wander free. Within a few decades, most steel bridges rust and collapse. Wooden houses rot, their beams broken by storms. Concrete, seemingly eternal, begins to crack and crumble without maintenance. After a few centuries, the forests return. Rivers swell to reclaim their courses, flooding suburbs and washing away roads. Roofs collapse into dust, skyscrapers topple, ports rot into the sea. Only the strongest monuments, the pyramids of Egypt, perhaps Mount Rushmore carved into granite, might still stand in some recognizable form. But even these would not last forever. In 10,000 years, glaciers might return, grinding across continents and pulverizing everything in their path. Rising seas might drown coastal cities under layers of sediment. Earthquakes would split landscapes and bury ruins. In 100,000 years, it is likely that almost all physical signs of our presence would be erased. What then would remain? Not our cities, not our machines. Instead, subtle signals. Carbon isotopes, recording our burning of fossil fuels. Plastics, reduced to microscopic particles but scattered through sediments. Radioisotopes from nuclear activity embedded in rock. These would be the signatures left behind, the faint chemical fingerprints of a civilization. Now turn the thought experiment backward. Imagine that a parallel intelligent species existed 100,000 years ago. Perhaps they mastered fire in ways we cannot yet detect. Perhaps they built with wood or biodegradable materials. Perhaps their population was small, their footprint light. If they vanished, how much would survive? The answer, if our own disappearance is a guide, is almost nothing. We might search for their ruins and find none. We might sift the soil and find only subtle chemical shifts or puzzling tool fragments that could be dismissed as natural. Their story, like ours would be, could vanish into the silence of deep time. Picture this. A future species digs into Earth's layers millions of years from now. They find faint anomalies in chemistry, strange patterns in sediments, perhaps a fossilized remnant of our species. Would they know that we once built global cities, dreamed of the stars, and created technologies that reshaped the Earth? Or would they see us only as a brief disturbance, a signal barely different from the noise of geology? If this is the fate of our own civilization, then why not for another? Why should we assume that we are the first? A thought experiment does not provide proof, but it reveals possibility. It shows us how fragile memory is, how quickly intelligence can be erased, and how easily a civilization can become invisible with the passing of time. If stone and chemistry are the memory of Earth, then DNA is the memory of life. Written in the language of 4 letters, A, T, C, and G, it carries not only the blueprint for bodies, but the traces of encounters across generations. And unlike monuments or tools, DNA can survive in fragments long after cultures and species are gone. In recent decades, scientists have learned to read these fragments with astonishing precision. From a single tooth in a Siberian cave, we discovered the Denisovans, an entire branch of humanity previously unknown. They left behind almost no artifacts, no monuments, no stories in stone. Yet their DNA persists in millions of people today, small echoes carried in blood, lungs, and bones. Their genes even help some populations thrive in high altitudes, a legacy of adaptation passed invisibly through time. Neanderthals, too, live on in us. Once thought to be entirely separate, they now appear as part of our lineage. Most people outside Africa carry 1 to 2% of their DNA. These fragments are not trivial. They influence immunity, metabolism, and even aspects of our physiology. Though their culture is mostly lost, though their graves are few and their tools scattered, their memory endures in the most intimate place possible, within us. This raises a striking possibility. If another intelligent species once walked the Earth, one whose physical traces have been erased by time, might we still carry pieces of them within our genomes? Could there be fragments of DNA, unexplained by known hominins, that hint at a lineage we have not yet identified? Already, scientists have discovered ghost populations, genetic signals from groups that left no bones, no artifacts, only their DNA embedded in ours. These ghost populations remind us that much of human history remains unwritten, even within our own bodies. If we can find traces of Neanderthals and Denisovans, we might one day find echoes of something stranger, something that does not match any known species. But here too, caution is necessary. DNA is not eternal. It degrades quickly, and even under the best conditions, permafrost, caves, sediments, it rarely survives beyond a few 100,000 years. And even when fragments endure, interpretation is fraught. Genetic mixing blurs lineages. Random mutations accumulate, obscuring origins. A mysterious fragment may hint at unknown ancestors, but it cannot tell us how they lived, what they built, or what dreams they carried. Still, the possibility lingers. Our very bodies may be archives of forgotten histories, libraries of encounters long erased from rock and soil. Perhaps we already carry the genetic whispers of another intelligent species, one whose tools have vanished, whose myths are gone, but whose legacy endures in the code that makes us human. Picture this: a laboratory, late at night. A researcher examines a strand of ancient DNA recovered from sediments in a cave. Amid the sequences of known hominins appears a fragment that does not fit, a genetic signal belonging to no Neanderthal, no Denisovan, no modern human. It is a ghost, a hint of something else. The researcher leans closer, aware that in this faint molecular trace lies the possibility of an untold story. DNA may not give us monuments, but it gives us something perhaps more profound: continuity. It shows that life is never truly erased, that even when cultures vanish and species fall silent, their presence may still echo in the cells of those who follow. If DNA is the fragile memory of life, then there are other signals far more enduring, marks of civilization so long-lasting they might outlive even the species that made them. These are the traces that do not vanish quickly, but instead fuse into Earth's very fabric. They are what some scientists call technofossils, the geological legacy of technology. Consider carbon isotopes. When humanity burns fossil fuels, the balance of carbon-12 and carbon-13 shifts in the atmosphere. These shifts become locked into soils, sediments, and even the shells of marine organisms. Long after our skyscrapers collapse, those isotopic fingerprints will remain as thin chemical lines in stone, quietly announcing that something unusual happened here. If another intelligent species altered the carbon cycle tens or hundreds of thousands of years ago, we might still find their signal in rock today. Plastics are another enduring marker. Born from petroleum and engineered to resist decay, plastics break down slowly, fragmenting into microscopic pieces that scatter across the oceans, rivers, and soils. These microplastics are already embedded in sediments worldwide. Over millions of years, they could fossilize into new types of rock, what geologists call plastiglomerates, fusions of plastic and natural stone. If another species once created synthetic materials unknown to nature, their remnants might still lie buried, waiting for discovery. Metals, too, leave behind durable traces. Even when tools and machines corrode, their residues persist in the environment. Smelting produces slag, an unnatural mixture of minerals and metals that does not occur without deliberate effort. Mining leaves scars in the bedrock, pits and tunnels that can, under the right conditions, endure long after collapse. If another civilization ever mined, refined, or engineered metals, the chemical signature of those activities may still be detectable. And then there are radioisotopes. Nuclear activity produces isotopes not normally found in nature, or at least not in the concentrations we create. Some of these isotopes endure for hundreds of thousands of years, their presence unmistakable to future scientists. Even if every reactor and warhead were gone, the rocks themselves would remember. These durable signals are striking because they show how intelligence can become part of geology. Our species is, in effect, writing itself into stone, not through monuments, but through chemistry. Rock is Earth's memory, and in the Anthropocene we are inscribing ourselves into that memory in ways that will endure far beyond us. Picture this: a cliff face millions of years from now. A geologist, not human but another intelligence, studies its layers. They find a sudden spike in carbon isotopes, a scattering of microplastics fossilized into stone, and traces of radioactive isotopes. No ruins, no statues, only anomalies in chemistry. From these signals, they infer that something once lived here that reshaped the planet in profound ways. Something like us. If such markers are the only legacy we leave, might not the same have been true of another intelligence before us? Perhaps their traces are hidden in sediments we have not yet studied, their signals misread as volcanic, or simply overlooked. Perhaps we are not the first to be written into stone. For all our confidence in progress, history reminds us that civilizations are fragile. They rise with brilliance and ambition, but their foundations are often more delicate than they appear. A few decades of drought, a sudden shift in trade, or a conflict too costly can bring even the grandest empire to its knees. If we imagine another intelligent species once sharing this planet, we must also imagine their vulnerability. Intelligence does not grant immunity from collapse. It merely changes the ways collapse can come. Look at our own history. The great cities of the Maya were once centers of astronomy, writing, and monumental architecture. Yet prolonged drought and internal strife scattered their people, leaving stone temples buried beneath forests. The Roman Empire, a vast web of roads and aqueducts, fractured under political and economic strain, its infrastructure crumbling into ruins. In Mesopotamia, soil salinization slowly undermined agriculture, contributing to the fading of once thriving city-states. These collapses happened in spans of centuries, mere moments in geological time. And yet, within those moments, entire cultures lost their complexity, their knowledge fragmented, their monuments reclaimed by earth and vine. Now extend this vulnerability to scales of tens or hundreds of thousands of years. Even a species as capable as ours, or more so, could vanish almost without a trace. They might have been undone by climate change, unable to adapt to rapid shifts in temperature or rainfall. They might have been struck by disease, a pandemic spreading unchecked through connected populations. They might have consumed their environment faster than it could renew, leaving barren landscapes where once there was abundance. And we must not forget the possibility of violence. Intelligence creates tools, and tools can become weapons. A war fought with technologies beyond our comprehension could erase whole populations and reduce once thriving societies to scattered survivors, struggling to remember what was lost. Picture this: a species that had mastered the art of building, of shaping landscapes, of telling stories. For thousands of years, they flourished. Then came a long drought, or a volcanic eruption, or a war. Within a few generations, their numbers dwindled. Within a few centuries, they were gone. Forests grew where their cities had been. Rivers erased the marks of their fields. Time did the rest. Civilization is a fragile experiment. It depends on balance between humans and their environment, between innovation and restraint, between cooperation and conflict. Break that balance, and collapse can follow quickly. Our own world demonstrates this. We have global communication, advanced medicine, powerful technologies. Yet even now we are vulnerable to climate shifts, to resource depletion, to the tensions that arise when populations outgrow what the planet can provide. We are not exempt from the fragility that has undone so many before us. If another intelligent species once lived here, their disappearance may not have been dramatic. It may not have been marked by a single catastrophic event. It may have been slow, quiet, a long unraveling until memory itself faded. That is the true vulnerability of civilization. It can vanish not with a bang, but with silence. When we look across Earth's long history, one pattern emerges again and again: disappearance. Species rise, flourish, and then vanish. Sometimes slowly, fading as conditions change. Sometimes suddenly, extinguished by catastrophe. Extinction is not the exception, it is the rule. For most species, the causes are natural. Climate shifts alter ecosystems. Ice ages advance and retreat. Food sources dwindle. Predators evolve, competitors arrive. Over millions of years, 99% of all species that ever lived have disappeared. Life is resilient, but it is not permanent. Intelligence does not change this law. It may alter the path, but not the outcome. An intelligent species may extend its reach, adapt more quickly, engineer its environment. Yet it also creates new vulnerabilities. The very tools that sustain survival can become the seeds of collapse. Consider the Toba supereruption about 74,000 years ago. It was one of the largest volcanic events in the past 2 million years, releasing ash across continents and triggering what may have been a volcanic winter. Human populations, already small, may have dwindled to near extinction. If an advanced civilization had existed nearby, it could have been erased entirely, its fields covered in ash, its people scattered, its memory lost. Asteroids are another pattern of disappearance. The Chicxulub impact ended the age of the dinosaurs, but smaller impacts have also shaken the Earth. A strike large enough to devastate even a single region could undo the stability of a civilization. Imagine cities reduced to firestorms, harvests failing under a darkened sky, survivors left to start over with nothing but fragments. Pandemics, too, remind us of fragility. Diseases leap from animals to humans, or from one group to another, spreading in waves. History records plagues that emptied towns and altered empires. For a species more ancient than ours, with no medicine, no vaccines, such an outbreak could have been final. And then there is self-destruction. The ability to manipulate fire, metal, or energy grants power, but power without balance can lead to ruin. Forests may be cut faster than they regrow, soils exhausted by overuse, rivers drained until they run dry. Wars may escalate beyond control, fueled by tools that destroy more than they preserve. The collapse need not be sudden. It can be a slow unraveling, each generation living with a little less until memory itself vanishes. Picture this: a species much like us, thriving on fertile plains, building structures of wood and clay, shaping tools, telling stories. Then, year by year, rains become less reliable, harvests fail, conflicts rise. A generation later, the great centers are abandoned. A century later, their people are scattered into smaller groups, living as hunters once more. 1,000 years later, there is no memory of the civilization at all. Patterns of disappearance teach us that intelligence does not guarantee survival. In fact, it may make a species even more vulnerable. The more complex the system, the more fragile it becomes. A collapse can come from a single point of failure, a single imbalance. If another intelligent species once lived here, their disappearance need not surprise us. It would simply place them within the same rhythm that governs all life on Earth: rise, flourish, fade. The mystery is not that they could have vanished, but whether we can find the faint signals they may have left behind. When we stand at the threshold of mystery, balancing the whispers of myth against the rigor of science, we find ourselves in a delicate place. Both myth and science are forms of storytelling, though their methods differ. Myth carries memory in symbolic form, bending truth into parable. Science carries memory and evidence, carefully tested and compared. When they meet, the tension between them can spark both confusion and insight. Myths, as we have seen, speak of giants, hidden peoples, and vanished teachers. They tell of floods that swallowed cities, of gods who destroyed civilizations, of other beings who lived alongside us. These are stories of loss, of beginnings and endings, of worlds reset. At first glance, they seem distant from science, yet sometimes myth and geology converge. Aboriginal Australian stories of the sea swallowing coastal plains match geological evidence of sea level rise thousands of years ago. Ancient Near Eastern flood myths echo the memory of rivers overflowing and reshaping landscapes. Science, on the other hand, demands caution. It warns us that natural processes can mimic intention. A volcanic eruption can look like deliberate burning in the isotopic record. Erosion can carve landscapes that seem like walls or statues. Mineral veins can mimic artifacts. A myth that speaks of giants might reflect the memory of Neanderthals, or it might be a metaphor for struggle and survival. But science also teaches humility. It reminds us that the absence of evidence is not evidence of absence, that most of Earth's history has been erased, and that much of life's story is still invisible to us. In this way, science and myth both remind us that our knowledge is incomplete. Perhaps the real lesson lies not in choosing one over the other, but in listening to both with care. Myth may preserve fragments of memory, altered but not erased. Science may uncover patterns in stone, chemistry, and DNA that give those fragments context. Together, they invite us to imagine without leaping to certainty, to wonder without abandoning rigor. Picture this. An archaeologist kneels in a cave, brushing away dust to reveal pigments smeared on stone. The symbols are abstract, enigmatic. Are they art, ritual, something else? At the same time, an elder in a distant community tells a story of hidden people who once painted caves and vanished into the earth. The scientist and the storyteller stand in different traditions, but both are witnesses to the same mystery, traces of others who came before. The danger, of course, lies in misreading. To take myths as literal evidence risks building castles of fantasy. To dismiss them entirely risks silencing voices that may carry deep memory. Likewise, to see intelligence in every anomaly risks error. To explain everything away risks blindness. The balance lies in humility, in admitting how little we know and how open the past remains. In the end, both myth and science tell us something profound. They tell us that the story of Earth is not neat, not linear, not easily contained in textbooks. They tell us that memory is fragile, that worlds rise and fall, that the traces of intelligence may linger in whispers rather than monuments. They tell us, above all, to wonder, what if our story is not the first? And what if it will not be the last? If intelligence has emerged once, why not again? This is the quiet question that lingers when we consider the long sweep of Earth's history. Our species, Homo sapiens, has come to see itself as singular, unique, the inevitable crown of evolution. Yet the evidence suggests otherwise. Neanderthals crafted tools and ornaments. Denisovans passed their genes into us, carrying adaptations still useful today. Homo floresiensis lived for millennia in isolation, small but capable. These examples remind us that intelligence is not confined to a single species, not bound to a single form. It is a possibility written into life itself, one that may have been realized more than once. And if it has happened more than once, why should we assume that we are the first, or more humbling still, the last? Evolution is not a ladder with a single rung at the top. It is a branching tree full of experiments. Some branches flourish, others wither, but the tree endures. Intelligence may be one of those experiments, arising when conditions favor it, vanishing when they do not, only to reappear again in another form, in another age. Picture the Earth's timeline as a vast scroll. For most of it, life is simple. Bacteria, algae, single cells. Then complexity blooms. Cambrian seas fill with creatures whose forms we struggle to imagine. Forests rise, reptiles dominate, mammals wait in the shadows. At intervals, catastrophe strikes, wiping away entire chapters, and the scroll begins again with new characters. If intelligence arose in some of those earlier chapters and then was erased, the scroll would not remember. Only the faintest signals, buried deep, would remain. Our own chapter may be just one among many. We look around and see the vastness of space, and we wonder if we are alone. Yet perhaps the more urgent question is whether we have ever been alone on Earth. The silence of deep time makes it impossible to say for certain, but here is the humbling thought. If another species of intelligence did once exist and vanished, then our existence is not unique, not permanent. We may be extraordinary, but not unprecedented. And if intelligence has risen before, it may rise again after we are gone. Perhaps in millions of years, when our monuments have long since crumbled and our names are forgotten, another species will inherit the planet. They may walk the same valleys, sail the same oceans, study the same stars. They may find our chemical signals in stone and wonder who we were. They may ask the same questions we ask now. Were we the first? Were we alone? The story of Earth is long enough to contain many such voices. We may be one verse in a greater song, a melody that echoes across ages, each refrain rising, fading, and returning again. And so, after all the whispers of chemistry, the fragments of bone, the myths of forgotten peoples, we arrive at the quiet center of the question: what if humanity once shared the Earth with another intelligent species? The answer may never come in the form we long for. There may never be a single artifact unearthed that proves it beyond doubt. No fossilized city waiting beneath the sands. Time is relentless, and its erasures are thorough. Yet the absence of certainty does not close the question. It leaves it open, inviting us to wonder. The deeper truth may be less about proof and more about perspective. We live in a universe that thrives on repetition. Stars are born, blaze, and die. Continents drift, collide, and reshape. Life itself has endured 5 mass extinctions, only to rise again in new forms. Why should intelligence be different? Why should we assume it has appeared only once? Perhaps other voices have already sung on this planet, their songs now erased but faintly echoed in stone and story. Perhaps their memory lingers in our DNA, or in myths of giants and hidden teachers, or in anomalies we dismiss too quickly. Perhaps we are not the first to dream of fire or language or the stars. Picture this: a long night under an open sky. Above you, the stars burn, silent and eternal. Beneath you, the earth turns, carrying within it the memory of all who have ever lived. You are one among billions, and yet part of something ancient, vast, and mysterious. The soil underfoot may once have been a city, a forest, an ocean, a world alive with beings we will never know. Their traces may be gone, but their possibility endures. The question, in the end, is not only about them, it is about us. If civilizations can rise and vanish, if memory is so fragile, what legacy will we leave behind? Will our signal endure in stone and chemistry, or will we too become another silence in the long record of deep time? Rock is the memory of Earth, and one day it will carry the imprint of our existence as surely as it carries the echoes of extinctions past. But what it cannot carry is meaning. That is something we must choose, here, now, in the fleeting moment we are given. Perhaps the most humbling possibility of all is this: our story was never just ours. We may be part of a cycle much larger than we imagine, one in which intelligence rises, falls, and rises again. The Earth has known many voices, and it may know many more. So tonight, as you drift towards sleep, let this thought linger gently. What if we are not the first and not the last? What if the story of Earth is not one of solitude, but of shared chapters, forgotten and yet enduring, written in stone, in myth, and in the fragile memory of life itself?